Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics. And these two particular questions belong to paper 9709/41 for the session October November 24. Let's go through question number 3 of this paper. Coplanar forces of magnitude 52 Newton, 39 Newton and P Newton act at a point in the direction shown in the diagram. The system is in equilibrium. Find the values of P and theta. One of the most interesting and easiest questions. So let's start the solution, and we know for solving such question we always apply the concept of the motion law of Newton. Before that, can we complete the diagram using our triangle? Suppose this is our triangle. Well, let us start resolving the forces horizontally as well as vertically. So if we resolve the forces horizontally, we will start writing. Let me change the color of the ink. Well, if we resolve the forces horizontally, we will show the symbol, yes, horizontal forces. And we are going to apply the most widely used concept of motion law of Newton. So driving force minus resistance force is equal to mass into acceleration. Let's see what is the driving force or onward force. This is, look at this, if we resolve the forces horizontally, only this is the force which is acting onward horizontally. So it is 39 Newton. So let us write 39 Newton, 39. 39 minus resistance force. Resistance is the negative force which is to this direction. The direction is negative. So it is going to be, if we resolve this force horizontally, it is going to be P cos theta. P cos theta is equal to mass into acceleration. Look at this. As the system is in equilibrium, there will be no motion at all. There is no movement. That's why acceleration is 0. So our right side is going to be 0. Now if we isolate our P cos theta, P cos theta is equal to 39. We may leave this equation as equation 1. And don't forget that as there are two values missing, P and theta, so we will have to form two equations and they should be resolved simultaneously. Well, for the next forces, we will resolve the forces now vertically. Let us use the symbol, vertical symbol. Okay, now let's see what are the vertical forces which is acting as driving force, upward and downward forces equal to MA. So driving force, I mean upward force. Let's see what is the upward force acting on the particle. Upward force is given as 52 Newton. 52. 52 minus downward force is acting through P. So if we resolve it vertically, it is going to be P sine theta. P sine theta is equal to mass into acceleration. As there is no acceleration, right side is 0. After that, if we isolate P sine theta, P sine theta is equal to, now it's 52, and we can leave this as equation number 2. Now if we solve the equations simultaneously, it is going to be, let me write just beside this. So it is going to be from equation we will write here, from equation, equation 2 can be divided by equation 1. If we divide equation 2 over equation 1, what is it going to be if we divide the second equation? Let us see the second equation. This is our second equation. Okay, our second equation is p sine theta. Yes, p sine theta, p sine theta over p cos theta, p cos theta equal to, equation number 2 was 52, and equation number 2 was 52, and equation 1 has 39 on the right side, so it is 39. Well, each of the p's can dissolve each other, so sin theta over cos theta is actually tan theta. Tan theta equal to 52. If we divide both the numerator and denominator by 13, it is going to be 4 over 3. Hence our theta is going to be, let it be not the final step, so one more step can be written. Theta is equal to tan inverse of 4 over 3. Hence our angle in between P and the horizontal ground line is, let us find tan inverse of 4 over 3. It is 53.13, so 53.1 degree. If we round it up to one decimal places, 53.13, this is one of the answer. But we should not forget that they told us to find the value of p as well as theta. So we have got the value of theta. Now simply we can write the value of p. Hence p is equal to, look at this, from here we can pick up this equation. P equal to what? 39 over cos theta. 39 over cos theta. Cos 53 point theta stands for 53.1 degree. Hence our P is going to be, let it be the final step. So the force, the force acting in the line is 39 over cos 53.1 equal to 65.00. So it is simply 65. 65 Newton is the force acting along this leaning line downward. So these two are the values of this question. So we have solved question, both of the parts of question 3. Let's move on to question number 4. And I think there is nothing complicated which is required to be discussed more. Let's move on to question number 4. 4 is over there. This is the question number 4. Okay, let's read question number 4. Question number 4 says, a bus travels between two stops A and B. The bus starts from rest at A and accelerates at a constant rate of a meter per second square until it reaches a speed of 16 meter per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 a meter per second square, coming to rest at B. The total time for the journey is 240 seconds. Sketch the velocity time graph for the bus's journey from A to B. Well, we are going to sketch the graph, which is a velocity time graph. So let us see. It started from the origin is it started from rest. That means from O it started. It may be A over here. Okay, this is A, and it started from 0. Then this is, let it be 0. Let it be the maximum velocity of the bus was what, 16. So let us write over here 16. Well, so if we start drawing, suppose here T1, T1, that means he reached the maximum speed at this time, and it may be T2, T2, T2. Then at the end of 250 seconds, at the instant of 240 seconds, 240 seconds, the bus came to rest again after decelerating at a constant rate. Well, so this is our first acceleration for time until the time is t1. Okay, then constantly it continued until t2, until t2. Then the bus started decelerating at a constant rate until it reaches the 0 as velocity. Okay, let me erase these unnecessary parts. Yes, this is unnecessary to be shown. Well, after that, here also there is an unnecessary part. Well, so this is what the sketch of the velocity time graph of this scenario, and we can assume this to be t. This is the time. This is the time between the time when the bus was moving at a constant speed. Well, let's see the question number B. B says find an expression in terms of A for the length of time that the bus is traveling with constant speed. That means they have told us to find this distance starting from here to here. That means T. We will find T. Well, so for finding the time, if simply we can apply the concept Schubert formula, and in this case, initial and final velocities in both cases are known to us. So if we talk about this portion, okay, in this portion and the final part, okay, this part, there are two triangles. So what is the concept we are going to apply here for finding the time between the length of time that the bus is traveling with constant speed? So first of all, if we choose the first triangle, we are going to apply the concept of Schubert formula. V equal to U plus AT. Okay, we know that this concept is very commonly used. So final velocity, V is final velocity. Final velocity is 16. Initial velocity was 0 because it started from origin, plus A. Acceleration, let us see, acceleration was also constant in the first phase. Acceleration was a meter per second. So we are just going to write A and T1. A T1. Okay. Hence we require actually time. Hence T is equal to T1 is equal to what? 16 over A. 16 over A. We may leave this as equation number 1 and we'll have to form two simultaneous equations because there are two values missing, T as well as A. Well, after that, for the second phase, that means the second triangle. again we are going to apply the same concept. The concept is, let my let my ink be changed. Okay, for the second one, v2. Okay, v2 is equal to u plus a t. Well, so final velocity in the final triangle or final last phase, third phase of the journey, if we look at this, we will find final velocity is 0, because it came to look at the once again. Let us see until it's coming to rest. Look at this, it came to rest at b. Okay, we can assume it to be b. Suppose there is b over here. So final velocity is 0. Final velocity is 0 equal to initial velocity. Let's see what was the initial velocity for the third phase of the journey. Initial velocity was 16. Look, it was here, it was 16. This is 16. Okay, at this point, so 16, then plus, but instead of plus we will use negative symbol, because this is not acceleration. Look at this, the line is negative line, negative straight line, so this is negative acceleration, means deceleration. And what is the rate of deceleration? It has been given that it was decelerating at the rate of 0.75 a. So we will write here 0.75 a, 0.75, 0.75. Now the time the change in time is 240 minus t2, 240 minus t2, minus t2. Well, we require actually time to be isolated. If we do so, we will have to get, if we multiply 0.75 and 240, it is going to be 180. So 180, there is a over here. So 180a, it is a. 180a, then minus 16 is equal to negative, not negative, it is going to be positive. If we multiply 0.75, then 0.75 t2, 0.75 t2, there is an a also in between them. Okay, now if we isolate our t2, there is an a. If we isolate our t2, then what is it going to be? Hence our t2 is equal to 180a minus 16 over 0.75a. Okay, we may leave this as equation number 2. Now solving this equation simultaneously, we will find the time in between these two phases. Okay, after that I think I should choose a place over here. Okay, yes. So they have told us to find, once again let us see the question. The question says find an expression in terms of a for the length of time, that the bus is traveling with constant speed. So actually this is the length of time, this from t1 until t2, and we may term it as t, larger t, I mean uppercase t. Well, so t2, hence t2 from equation 2 and 1, if we write t2 minus t1 is equal to, what is there in the right side? First t2, t2 is, let me zoom it out, otherwise this space is not sufficient to be written. Okay, 180a minus 16, 180a, 180a minus 16 over 0.75a. This is the equation number 2, minus equation number 1. Equation number 1 was what? This is equation number How can it be equation 2? It was equation number 1. It was equation number 1. Okay. So equation number 1 was t equal to 16 minus a. 16 over a. So we will write minus 16 over a. 16 over a. Okay. Then t2 minus t1 is supposed to be our time between the it is length of time, so we can term it as t. Okay, as t equal to, if we simplify here, what is it going to be? It is going to be 180a 180a over 0.75a 0.75a minus 16 over 0.75a 0.75a minus 16 over a. Well, hence our t is going to be here. If we dissolve, I mean, if we divide 180 by 0.75, it is going to be 240. 240 and a will cancel each other. Then here, if we divide, let us simplify this. So our denominator is 0.75a, hence it is going to be 16, and plus here you will have to multiply 16 by 0.75. If we multiply 16 by 0.75, it is going to be 0.75 into 16, which is 12. So it is going to be 12, 12, or t is equal to 240 minus it is 48. Okay, so if we multiply 48 by 0.75, it is going to be, no, we will multiply both the numerator and denominator. Okay, so 4800, it is going to be 4800. 4800, if we multiply both the numerator and denominator by 100, then it is going to be 75. Okay, then hence our t is going to be, what is our t going to be? 240 minus, look here, by how much can we divide both the numerator and denominator maximum? The HF between 480 for 4800 and 75 is actually 25. So by 25, if we divide 4800, it is going to be 3800. Yes, I made a mistake over here. It is going to be 3800, not 4 at all. Let it be written as 3. Okay, now if we divide this 3800 by 25, it is going to be 4, sorry, not 3 even, it is 2. So it is actually 2. 2800, let me write here 2. So 2800, if we dissolve 2800 and 75 by the HCF 25, it is going to be 4 2 8s are 112, 112, 112 over, if we divide 75 by 25, it is 3. A. In terms of A, this is what the answer is. Okay. So finally, what have we got? Okay, let me write this above the denominator. Okay, it looks better. So this is what the solution to question number B of this question number 4. So our answer, this time, the length of time between the instant when the particle was, the bus was at a constant speed. Let's see what the next question says? The next question says, given that the distance from A to B is 3000 meter, find the value of A. We know distance is nothing but the area of the traveled line. Okay, so it is nothing but a trapezium, isn't it? So in this trapezium, we will find the area of this trapezium, which is the total distance. So total distance is written. What is the total distance written? Total distance. Total distance. How much is the total distance? It is 3000 meters. So we will write the 3000 meters. So total distance is, the area of the region which has been traveled by the bus. So let us find the area. This is nothing but a trapezium. So area of the trapezium is first the half of sum of the parallel lines. So parallel lines is what? First it is 0 until 40. Okay, first one is 40 plus parallel lines. The other parallel lines is this portion, which is t. Okay, so t has already been obtained. We have obtained t equal to what? T is equal to 240 minus 112a. So 240 minus 240 minus 112 a over 3. Well, into the formula, we haven't yet completed the formula is then distance between the parallel lines. What is the distance between the parallel lines? The distance between this line and this line is what? It's nothing but 16. So it is 16, and our right side is 3000. 3000. Well, if we divide this 16 by 8, so 8 will go to the other side. On the left side there remains 24 plus 240. What is it going to be? It can never be 24. This is actually 240. By mistake we have written 24, because this is the first parallel line. The longer parallel line is 240 seconds, A to B. Okay, 240 plus 240, it is 480. 480 minus 112a over 3 equal to, it was 8. So if we divide 3000 by 8, is it divisible? Yes, it is exactly divisible. So 8 threes are 24, so 6, 8 sevens are 56, then it will be 40. So it is 8 fives are 40. Well, after that, if I continue writing just below this, it is going to be, look, 1 2a over 3 equal to minus, if we subtract 375 from 480, it is going to be 105. 105. Well, or we require a. Okay, our a is going to be it should not be negative, both of them are negative actually. So a is equal to a, we can use hence symbol. Okay, a is equal to 105 into 3 over 112. Hence our acceleration, I mean the final value of a, let us do the multiplication. It is not divisible by any numbers. No, we have made a great mistake over here. It should not be like this. The fraction has been formed wrongly. So it is going to be, first of all, there was what? 105. 105 must be the numerator into, from the left side if we bring 3, it is being transposed, so it will be numerator, no more denominator, and this is 112. Okay, by 7. By 7 if we divide this one, it is going to be 15, and by 100 and by 7 if we divide 112 by 7, it is going to be 16. So it is nothing but 45 divided by, look, already we have made a mistake over here. Actually the mistake was made over here. This a was not numerator at all. This is not a numerator. Look, this is actually denominator. This should be, this a is denominator. By mistake we have written as numerator, so this is not numerator, this is denominator. So 3a will go downward. If we write 3a instead of there, it is not a over here, a is the denominator, so it is going to be denominator. Then if it is denominator, then what is it going to be? Well, we are supposed to isolate this a. Okay, if a is taken to the other side, then it will be numerator. Well, yes, we have got the concept. If a is transposed, a will be numerator, but 105 will go downward, so it is to be erased. The fraction we should form is, so our fraction is going to be, as a has been transposed, so this fraction 112 will remain as it is 112, and it is going to be 3 denominator, and from the right side 105 will be transposed as denominator, because it was numerator, now it is denominator. So finally we will have to divide 112 by 315. 112 over 315. Let us do this division. Yes, if we do the division, 112 significant figures, 0.356 meter per second square is the acceleration, but we don't need to write the dimension because it's already given. So this is what our final answer. That means there are three parts of the same question. First part we sketch the figure, which is a velocity time diagram, from which you can find the total distance. Total distance is the area traveled by the particle or object. And here in this case, this area is actually a trapezoidal region. So if we find the area of this trapezium, then we get the total distance. And I think you understood as I have told. Fi amanillah. May Allah bless us all with the beneficial and humane knowledge. And the first one was, this was the first one.